Have you ever wondered what it takes to power the devices we use every day? How do our phones use batteries to turn on and off? How do they get the charge in the first place?
Electrochemistry is the branch of chemistry that deals with the relations between electrical and chemical phenomenon. Electrochemistry is the science behind what powers our phones and almost every other electricity-powered device item.
In order to fully understand the functionality of our devices and open windows into making our own devices in the future, we have to understand how the batteries are made and how they function.
First, we need to understand that redox reactions power batteries. Redox reactions are reactions that involve the reduction of one element and the oxidation of another. Redox reactions are powered by the transfer of electrons.
Redox reactions are comprised of reduction and oxidation sequences. Reduction is the gain of electrons by an atom or ion. The oxidation number decreases or is reduced as a result. In half reactions, these electrons are found on the left side of the reaction arrow.
Oxidation numbers is like in a high school popularity circle. As one queen rises, the other falls. As a part of the cell is oxidized, the other is reduced. This keeps things interesting in the school the way that this gives the cell power.
Oxidation is the loss of electrons by an atom or ion. The oxidation number increases as a result, making the element more positive. In half reactions, these electrons are found on the right side of the reaction arrow.
There are other ways to determine oxidation or reduction aside from observing the changes in oxidation numbers.
Oxidation involves gaining oxygen as the reaction progresses. Knowing this can lead to other deductions. Reduction involves losing the oxygen as the reaction progresses.
Here's another trick. Oxidation can be seen by losing a hydrogen atom. We can also make other deductions based off this information. Reduction can be seen as gaining a hydrogen.
Reduction and oxidation occur at different sections of the cell. The cathode hosts the process of reduction. An easy way to remember this is by thinking red cat. The anode hosts the process of oxidation. A good way to remember this is by remembering the phrase anox.
During electrolysis, electrons flow from one section of the cell to another. The electron flows from anode to cathode.
The parts of the cell have different charges. The anode is negative. This receives most of the negative ions. The cathode is positive. It receives positive ions. Also, in the cathode, oxidation agents are reduced. This may sound backwards, but the same idea works for the anode. In the anode, reducing agents are oxidized.
Reactions in the cells occur with aqueous solutions to make reactions more safe and easier to complete. However, there are other factors that allow for the cell to function properly.
Cells have a salt bridge which allows for the flow of ions. A commonly used ion in the salt bridge is KNO3. They also have a voltmeter that shows the voltage of the reaction. This helps chemists determine the net energy produced by the cell.
It is important to remember that the cell is a circuit. When any aspect of the cell is open or left off, the circuit is open, so energy will not flow and the reaction will not occur. A circuit is like a tire on a bike. In order to work, all parts must be there. If one part is missing, like the salt bridge or voltmeter, or the rubber tie, or the brakes to control, it will not function and the user will lose control, or in this case, the cell.
There are two types of cells, electrolytic and galvanic. Thermodynamically favorable reactions occur in electrochemical or galvanic cells. This means that the reaction is spontaneous. Thermodynamically unfavorable reactions occur in electrolytic cells.
Walk you through step by step on how we would solve one of these redox reactions. So first you're just going to write down your reaction and make sure that is nice and balanced.
Next, we are going to assign oxidation numbers. So any element in its periodic state will have an oxidation number of 0. And then next we are going to look at how the oxidation numbers change between elements. So we know that reduction is gaining electrons, therefore it would become more negative because the electrons are negatively charged. So the Cl is the reduction, half reaction, and the iodide is the oxidation because it is losing electrons, therefore it is becoming more positive. Next we are going to isolate our half reactions, so we are just writing them out without them being in the entire whole reaction of the cell. Also, we're going to balance the reactions by having 2 of each element on each side, and we also need to make sure that we balance the charges, so we're going to add in some electrons. That way the charges balance out and one side isn't more negative than the other. Alright, so now we have added in electrons on both sides so that the charges on both sides are equal to each other, so each one has a charge of -2 actually for both half reactions. So now we are going to combine the reactions, so we're going to cross out anything on opposite sides of the arrows that would cancel each other out, and then we're going to just mush them together the way that you would do an addition problem. Since both half reactions have 2 electrons on both sides, we're going to just go ahead and X those out. Alright, so we basically just added them together. As you can see, these 2 carry down to this side and these 2 remain on this side over here. So to find the voltage of the given reactions, we look at the reduction potentials. However, since this one is oxidized, the iodine, we have to flip the reduction potential so that it is negative instead of positive, and if it was already negative, you would just go ahead and make it positive. So we just go ahead and add these values together. I'll put a little addition sign right there so we can remember. And then the sum of these two is 0.82 volts. So basically all of this work helps us find the E cell, or the voltage that this reaction would produce. So here we have the ionic equation of the anode and the cathode and the volt that they would produce.
Cells have many different functions. Electrolytic cells can be used to separate pure metals from metallic compounds. They also have many other uses. These cells can also separate chemical compounds like water via electrolysis. Cells have more practical uses as well. Electrolytic cells can be used to electroplate metals.
Electrolytic cells have a wide variety of uses. Electrolytic reactions eventually slow down because the reactants become used up.
Galvanic cells have many uses also. However, they function a little differently than electrolytic cells. Galvanic cells work to convert chemical energy to electrical energy. This helps them power many devices like phones and radios. Galvanic cells power items when turned on with a switch.
To power a phone, one would use the electrolytic cells in a battery. Then, energy stored in a galvanic cell would be released when the on button was switched on, because this process would close the circuit and allow for the flow of energy.
It's time for a quiz. Let's see how much you remember about electrochemistry.